Hi, hello. So I'm Mateusz, or you can call me Matt, like the short for Matthew. I'm from L2BEAT. I'm half of the tooling team in the L2BEAT. And my workshop is on the discovery. It's the tool we built to help us research projects. And it turned out that it is really useful at solving all of our problems. I mean, not all, but like majority of problems I'm going to later talk about. So a funny story is that I almost lost the demo part of this presentation, and the only surviving copy of it was like some random Vim buffer. So yeah, I just wanted to point it out. Okay, so there is a lot of projects on L2BEAT. You know, the amount of project is growing, and we internally expect there to be at least 1,000 L2s. So currently, you can see that there is 51 rollups and 66 Validium and Optimiums. So around, let's call it 110 projects of only L2s. We also track bridges, not to the same standard, but for all of those L2s, we have a minimum bar of data we want to show, and that would be the risk rosette. We want the risk rosette to be obviously correct, and the standard for this data is actually quite high. We want to show data that is correct, so you don't lose your funds, you don't make a decision based on our data that is incorrect. So how to even maintain all of this, right? So just like a quick math lesson, right? So imagine that we have 110 projects, and every project has a single update every 2 months, right? So it's actually quite sparse. We see projects that are updating way more often. And even if every project had a single update every 2 months, we would have an 84% chance of seeing at least a single update in a day, right? So it's basically guaranteed that every single day something new will change on chain. We need to be able to detect it, see what's changed, and act upon it. And also, like, even if we assume that an update happens every 6 months, the chance is still 45%, right? So it's like a coin toss, basically. And these chances are basically always working against us. The more and more projects are going to be added, the higher those chances are basically to be 100%. So what is our needs, right? So like I said, there is a high chance of an update happening, and we need to be able to fastly see that it happened, and we need to be fast in reacting to it. If, for example, Arbitrum or Optimism, right, any of the top dogs has an update, and we take like 3 weeks to process that update, or to even like see that an update happened, then we are showing incorrect data for 3 weeks, which is actually a quite long amount of time when it comes to Web3. When an update happens, we need to know what changed. So it's not enough to see that something has changed. We also need to know what has changed, right? So did any of the risks assumption that we had before are now different? So also, we need to be able to look inside the project and compare to the previous version. And as always, we want to automate as much as possible. You cannot get to 110 projects listed on a website and do all of them manually. Like, it is possible with human effort, but we don't have the amount of resources to do it. So right now we have 4 researchers, and we maintain all of the 110 projects with only 4 people, and we also manage to do stuff that's additional. So discovery essentially, like, I think, is at the core of solving all of those problems. Of course, discovery is not a panacea. It does not solve all of the problems by itself. But of the problems that I listed, discovery is always at the core of the solution. So the mental model of discovery is like this. Like, I like to think about discovery this way. And also I like understanding things from the low level. So let's try to understand the inputs and outputs of discovery. The input, of course, is the Ethereum state. We want to see what is the state of each project on a given, let's say, block number. So the input to discovery is that Ethereum state. Of course, we are not sending like a snapshot.zip to discovery. We are doing something like, I mean, we use RPC providers, which is essentially having the entire Ethereum state at your fingertips. You can do any call you would like. And to facilitate the querying the data from the state, we have a config.json which instructs the discovery program which data we are interested in and how to process it. And after passing those two inputs to discovery, an output is generated, which is a discovered.json file. Of course, it's all a simplification. The more like the actual mental model, which I don't even think is correct, and is missing some parts, it's more something like this. So that's what I mean when I say like the discovery is at the core, right? Like all roads lead back to discovery. I'll try to, during this workshop, I'll try to touch upon all of the things that are listed here. So you'll be able to understand at least how this flowchart happened. Okay, so since I myself am a visual person, I want to show you a demo of something nice to look at. So this is something we have been working on, which will enable us to move from command line to a graphical user interface. So right now we are calling it Discovery UI, and let's see like all of the projects that are listed here are projects that we are tracking with Discovery. So I have picked Zora for the project we are going to be using during this workshop. So let's see what kind of data we can expect to see in this tool for Zora. So of course there is like a lot of things to take in, but let's start from the left and keep going right. There are on the left, the thing is that they look like files, but they are actually contracts. They are kind of inspired by the file view in Visual Studio, and you can see, maybe, I don't know, the contrast is not the best, but I hope you will see that we have two contracts which are the initial contracts. And by initial, I mean the contracts from which we are going to be starting, and all of the contracts that are on the left have been found based on those two initial contracts. So it is, as you can see, like it is quite useful to be able to find two contracts used in a project, and then basically find all other contracts used by that project. And also this updates automatically, so if anything new happens, new is added or is removed, they are automatically updated. Each of those contracts has some values, right? So each contract has an address, a name, a description given by a researcher, and let's focus on the fields for now. So fields are state variables that we have found in the ABI, which are either public variables or functions which don't take any arguments and just return something. So we are trying to build the state of the contract through these. There is also one more part which will be important later during the demo. I mean, during like the workshop part, which is that we try to build arrays from functions which take a single argument, which is of type integer. So we just assume that this function is like get something by index, and we try to get all of those things. And you can see that there are actually addresses inside of those values. And those addresses lead to other addresses. And this is how discovery works. It gets all of those state variables, and then if it finds an address, it assumes that this address is also connected and just keeps discovering on those addresses. And the third view here is like a graph view. So all of those projects here are used in Zora. And the way that it works is, for example, let's focus on the Security Council. Maybe not that, that's not the best, but the system config, right? So you can see that there are some state variables, and they point to other contracts. Through this view, it is really easy to understand how the project is built, what contracts reference each other, and how the data flow inside the project happens. Of course, this is not the default view. Like the view allows you to select them, move them around. You can color these, whatever your heart desires to make it easier for you to understand. We have two layout algorithms since it's a graph view. You can use like D3. We called it slow because it is not that fast. It uses force simulation to lay out the graph. We also have more like a hierarchical view, which just lays the graph from left to right. And the third thing is the code. So all contracts have source code. And let's go back to the L1 standard bridge example. And we want to show the code to the researchers, because to understand what a contract actually does, you need to look at the source code. And you might be weirded out by the fact that there are only 2 files. I'm going to touch upon this a little bit later, because it is actually quite important why there's only 2 files and not like more. So yeah, you can just view the code in here. The part that I want to also show is that we see that it is important to be able to switch between views, right? So I can click L2 output oracle on the left in the list view, and it is selected in the values and the nodes panel. Vice versa, I can select something in the values, and it is selected in the list and the nodes view. And I can select something in the nodes view, and it is selected on every single other view. So this is something which is like really graphical and nice to show, and it basically is only the look inside the discover JSON. This is just a nice way to visualize what's inside the discover JSON, but it doesn't touch upon the way of how we even got that discover JSON, right? So it is something we are working towards. It's not yet ready. You can only view things. It's basically read only at this time, but in the future we hope to make discovery this. So you'll be able to do your research in a nice graphical environment and do anything you need. So yeah, let's get back to, yeah, go ahead.
So you were showing the source code, but the source code is not on chain, right? So how do you get this?
Yeah, so the question is, how do I get the source code since it's not on chain? So I kind of skipped one assumption, is that by the Ethereum state, we also kind of consider the Etherscan source code database. Even if you go to L2BEAT and look into the projects that we list, if a project does not verify their source code on Etherscan, we give them like a big red warning. So we expect you to verify your source code to show transparency to the users and to the researchers so they can do their stuff. So it is something that are omitted, but we do use Etherscan or like Etherscan derivatives like BlockScout or stuff like that to get the source code, and we heavily rely on the source code, because if we didn't get the source code, we wouldn't be able to call anything because we don't know what the ADBI is, right? So yeah, if you have any questions, do please shut them up during the workshop. But I'll get back to the presentation.
Sorry, I have one more
yeah.
question just following up from that. So if you run into something where you can't get access to the source, you don't try any kind of decompilation?
We don't try it, and?
You don't try to decompile?
No, I mean, there was one case where we knew what the source was, it just wasn't verified. So we like forcefully, like we verified the source code for the project because they didn't want to do it for some reason, so we just did it. And we are not trying to decompile the bytecode in any way. I mean, if it's something that we can't get the project to verify and we need to look inside, we might decompile it, but Discovery does not try to do anything like that. It just assumes the happy case where the source is on Etherscan or whatever explorer the chain is using, and just goes from there. But yeah, if we hit a snag like there is no source, we just either accept it as we cannot look inside, or we talk with the team to verify the source code. Okay, if there are no more questions, I'm going to keep moving forward. So going back to the mental model, because I think it is really important, like if you leave this place with a single thing, it's just that Discovery is just a program. It has some input, it has some output, right? So the output is this Discover JSON, and the input is the config JSON-C. And the way you can think about Discovery, if it like makes thinking about it easier for you, is that it's like a scraper for a website. So scraping a website looks like you put some address of a website, it downloads the content of that website, it tries to find any links, and it follows those links recursively. Discovery essentially does the same thing, but it doesn't download websites. It downloads the state of contracts, and doesn't follow links, but follows addresses to other contracts. And of course, Discovery is not just like a simple thing that is like a black box. There are things happening inside that we are going to be talking about a little bit. So Discovery is able to detect whether a contract is a proxy. It does the source code flattening. I'm going to be talking about it later, like I said. It does template matching. It is something that also we are going to be touching upon during the demo part. It has custom handlers, which it executes. We are also going to be doing that during the demo. And it has typecasting. I left typecasting out because it is really, it would take like 20 minutes or 25 minutes to explain all of it. So I just left it out. If we have time or you were interested, you can hit me up after the workshop and I'll be glad to talk about it with you. And of course, there's like an engine that orchestrates everything. But yeah, it's like there are things inside that black box. So I have a demo prepared. There's a QR code. If you want to follow along with me, please do. And if you get stuck, I'll be able to help you gladly. I'll be going over the same thing personally. So if you just want to sit and just listen, no problem. The website has instructions, so you can do it now or later, whatever. And also, I really hope that the website works for you because like it's self-hosted. So if it doesn't work, try it, disabling your VPN, try a different country. I tried it like 5 times, it worked without any VPNs. So I'm going to give you like a minute to get to the website if you want to follow along. And yeah. Okay, I expect everybody to be on the website right now. If you didn't manage to scan the QR code or type it through, just ask your neighbor for a nice deed so they'll be able to show you the URL. Okay, so like I said, I'll be going over the same thing. Personally, I have it on my iPad, so I'll be going over all of the things that are written in here, and also I'll be like adding some additional context for it. And also, this is the important part. I forked Discovery from the L2BEAT repository just for the purposes of this demonstration. If you actually want to use Discovery yourself, please use the original repository because I'm not going to be maintaining this fork, and this could get really stale really quick. And why did I fork it? It's just because we are not, it's an internal tool. We will try to make it more available to the public. It's just, it is in a rough state right now, but it is still cool to show what this tool is able to do. Okay, so is this visible? Like the contrast is okay? Okay. So I have downloaded the only thing that I have done is just npm install. And if it worked, you should be able to just do npx discovery and something along the lines of this should appear. So there are two subcommands. You don't really need to worry about them. So there is the single discovery. It's just for convenience. If you really need to discover something like a single address, you put it there. But if you want to build like a project, you'll be writing a config.json either way. So there is also invert. Invert is like, we used it to build those graphs you saw. We used Mermaid before we got the protocol bit I was showing. So yeah, don't worry about those. The only thing that you're interested in is discover. So the most boring part of doing anything fun is setting it up and configuring it. Unfortunately, I'll have to leave the part of configuration to you. You need to configure two things. You need to configure the Etherscan API key, so you can actually call Etherscan. And you need to configure an RPC URL. And the sad part is that only few RPCs work that well with discovery. I'll say that the free tier of Alchemy worked for me without problems. So if you have Alchemy, do use it. There is like an asterisk where RPCs that only support block ranges of 10,000 when you're calling for logs do not work with discovery. For simplicity, we are essentially like expecting you to have an RPC where the block range for log squaring is basically infinite. So yeah, you'll have to set this all up. I'll just copy my env from the previous tries of that. So I have an env, and you should probably do the same. You can always like export the same variables if you want. So now we can get to the actual fun part. And before we actually configure anything, we need an initial address. The address in the website is already there, but like this is also a good question. Like, how do you actually get a hold of like any address that belongs to a project? And I'm going to show you like a simple example that you can find addresses belonging to a contract to a project. So we are going to be doing it this way. So like I said, I chose Zora for this presentation. So let's just go to the best website and find Zora. And how I do it is just go to their website of any project and try to bridge something. And also it is important, there are multiple bridges for Zora, for example, but what you want is the official bridge. I know it's a touchy subject, but in L2BEAT, we assume that the official bridge is part of the rollup. I don't want to get into it, but make sure you have the official canonical bridge to use. And we just want to bridge like the smallest amount of ETH. And please don't bridge anything. We just want to get to the part where it says sign. And don't sign, please. We just want to get to the part where it shows us the address we are going to be interacting with. So let me just bridge some ETH. Yeah, whatever. Okay, so this is the address of the contract we are interested in. And we can just copy it and store it for later. So now, how do we configure the discovery to start at that address? So we need to create a folder structure that discovery is able to understand. So this folder structure looks like this. So just, I'll type it out here. So discovery is the folder where all of the projects that you will use live, basically. And they're like configurations, results, flat files, source code, anything that pertains to a particular project lives in discovery. And the actual project is like that. So anything that related to Zora lives in there. But there's also one more level, which is Ethereum. This is the actual chain you're going to be doing discovery on. Because we have the ability to do discovery on multiple chains, like I showed, maybe I'll go back. And the discovery why. So if you look here, most of these projects say Ethereum. But for example, ZK Nova says 10 chains. That's because a project can have contracts on multiple chains, and the way that discovery works is any EVM chain just works. It just, you don't really need to think about it. You just say that you want to use that chain. Of course, you need to configure the RPCs for it and the Explorer for it, but otherwise, it just works. So yeah, this is the path we want. So discovery /Zora/Ethereum. And in that path, we want to create a config.json C file. The C is for comments. It is also, there is many parts where you can see that it's not that ready for public release. I think discovery will fail if you don't provide, like if you just do .json, it will fail. So it is touchy. Okay, so what are we going to put into the config.json? So it is an object where you have to define two redundant keys, which is chain, and that's Ethereum, and also name of the project. So why do we have to type the name twice? Since it's already in like the folder structure. It's just for simplicity. If you want to read this config.json in a different tool, you'll still know for which project it is. And now we get to the simple part. There is also one more key which just says like what is the initial addresses. You can have multiple. We're just going to put the single one.
The name doesn't, it's like there's no validation of the name, but it's written on the name, right?
No. So the way we do it in L2BEAT is that we have a bunch of tests that just validate if the config you have created is of what we expect. We also have like a bunch of assumptions where the name of the chain in the config is the same as the slug on the website, but we have tests for all of that. But you can put anything. Like you could put your name inside and it will just work. It's just like there is some schema that the discovery needs to see, and it's just like filling it out. But yeah, it's just a string, like as discovery is concerned. Okay, so we have put the L1 standard bridge as the initial address. And since this is a JSON C file, you can put comments. So L1 standard bridge. We are trying to, I know that half of the research team is trying to enforce this standard, and the other half doesn't really try. But yeah. So now what we need to do is we need to run it. And this is another part which is like not the best, which is the way that the ordering is done in the folder structure is project chain, but on the CLI it's the other way around. So you need to do Ethereum Zora. And if you did everything correctly, it should start spitting out logs. The first run takes a little while, and if it fails, you'll probably know it failed. But the interesting part is here that we have gone to this address. Through the source code, we have found that it's named L1 standard bridge, and we have found four relative contracts or entities, like also UAs, referenced by this contract. And as you can see, like we are putting those relative addresses back onto the stack, and we are rediscovering them all. And ideally, at the end, we have 61 contracts or EOAs, and the discovery is done. We have like limits, so there is like a depth limit of I think 7, and there is also a max address limit. So for certain projects that we don't really know, or for like big bridges, the amount of contract is really big. The biggest project we have is Transporter, which has 350 contracts, and is really like it is mostly just a stress test for discovery. So also pro tip, since like I showed you before, the mental model of discovery is this input-output, like a functional programming paradigm or whatever, is that you'll need to be rerunning discovery a lot. So like you saw, it takes some time, but if you look, there is a handy dandy cache. So discovery caches all of the calls you have made to a file. So if you need to rerun the same discovery, it already has all of the RPC and ETH scanner responses. So if you just pass --dev, I know the name is not the best, it will just reuse the block number of the previous discovery, and if you look at the speed difference, it's night and day. So please use --dev on any any reruns which are not the first run. So let's.
Is there a way to do this where you only are getting like 10,000 blocks at a time? Or is that a flag?
Of logs?
Blocks.
Yeah, blocks, but by blocks, what do you mean?
Oh, by RPC.
Yeah, that's the problem that I was referring to. Are you using Alchemy? Yeah, so QuickNode is something that we don't. So we are using QuickNode for everything except discovery, because it has this problem of only 10,000 blocks. We had code that managed the thing that you're referring to, which is like we did downloads by 1,000 block batches. It's really stupid. Like we had more time spent on trying to make it work than just like paying for a high Alchemy tier and just like doing whatever. So like I said, try to make a free Alchemy account. You can put Gavin Belson at Gmail or whatever. It'll be easier. I know that there are also like some public RPCs that support like infinite block range. For example, Envio. It's so envio.dev, but they only support logs. They're like really like a static indexer. But if you look into the README of Discovery, you'll be able to set it up. You can put like 2 RPCs. One is for everything except logs, and the second one is for only logs. Okay, so let's look. We have run the discovery, so let's look what it created. So we have 2 new entries. One is a discover JSON file, and the other is a .flat directory. I'm saying this, I think, for like a millionth time. I'm going to talk about flat files, but let's focus on the discover JSON for now. So in this file are basically all the things we have found during discovery, and we just like put every single thing into this file to try and make it as redundant as possible. If you look through the things, we have, of course, repeated Zora Ethereum, the block number at which we have run this discovery, the config hash, so if the config changes, we of course need to rerun the discover JSON. and the contract list. So the contract list is the thing that you're most interested in, but there is also an EOA list, so all of the EOAs that we have found, and an ABI list, so the list of all APIs attached to any implementation that we have found. And use templates. I'm going to talk about templates later. So each contract is an object. It has a name, it has an address, it has source hashes. Not really that useful to talk about it right now during the workshop. If you want to know, approach me later. Since timestamp, it's like when was this contract deployed. And values. Values is the thing that we are after, basically. It's the state of the contract at a given block number. So the state of it, like dollar sign something, is like a virtual field. We have created it ourselves based on some other values. But anything else is a state that we have been able to get just by calling the methods provided by this contract. As you can see, there are addresses like this, and some version stuff, whatever. There are things that are really useful in here, and stuff that is completely not useful in here. So you'll have to go through it and see if anything you would want to use is here. As you can see, like looking at all of this is not that pleasant. So we have also made, I mean, this was like before anything else. Before this thing, this is the OG way to view the discovery JSON. So if I just, oh my God, like I should find the guy who made the decision to make Finder like this. Okay, so we can pull this into the ProtocolBeat tool. ProtocolBeat is the same thing as node view in here. So this view and ProtocolBeat is the same. It's just it is easier. You can just drag and drop your discovery JSON into here. If you want to use ProtocolBeat, I didn't think about it, but I don't have a QR code. You can just protocolbeat.l2beat.com. And it should just work for you. You can do all the things that I showed in the discovery UI. But yeah, let's get back to here. So there are a lot of errors, and what we want to do is get rid of them. And the thing that I was talking about, maybe you remember, is the errors are here because of the way that we build some of the state. Like I said, we do some assumptions during the initial discovery. So we made some assumptions that were faulty. One of the assumptions was that there is some finite amount of elements in an array. Turns out maybe it's not an array, maybe the amount of elements is bigger. So if we look, so let's try to find this is finalized in the discovery JSON. Okay, so we have is finalized, and we can see that there is an error. And here it is sanitized because we had problems committing our API keys to GitHub. But in the ABI, if we look for the same thing, we can see that we put an L2 output index, and it just says to us whether this index is a finalize. There is like too many indexes to contain, and also it is not that important. If we are really interested in, what we would much rather see is like the count of indexes that are on this project. I mean, L2 output, how many of these are there, but we are not really interested in any single one, so we can just like tell discovery, hey, listen, don't call this function, ignore it, because it's giving me errors right now. So I'm going to show you how to tell discovery just to ignore this method when doing discovery. So what we need to do is we need to find the contract on which this error happened. So as it happens, in the error output, we get the address right here. So we can copy that address and get to the config. So let's go to the config. And now we need to do some configuration per contract. So to do that, you need to create a new key, which is called overrides. And now we need to specify that you want to override some things inside this contract. And now we need to say what you want to override. So for this contract, we want to say, hey, ignore methods, and we are going to supply the methods we want discovery to ignore. So just copy paste and rerun discovery. Okay, we are down to 6 errors. If you want, you can try to ignore more errors yourself. I'll give you like a minute to see if you got the hang of it. I'll leave you with the config so you have a cheat sheet. Yeah, so the biggest hurdle we have is mappings, like you say. If there is some mapping and there are basically no getters for it, it is really hard. So what we usually do is that if the source code is sensible, it'll basically always emit an event when it inserts something into that mapping or when it overrides it. We then build the value of that mapping based on the events. So we query for all of the events and we rebuild the mapping state based on those events. But there is like no automatic way to do it. You have to look at the source code, you see which events are there, and rebuild it yourself. I'm going to talk about handlers later, but we have handlers for that, so we can do just that.
While we're waiting, you have a long list of L2s, and you've said that you expect, 1,000 or more. That's probably right. So how do you get started with this? Like, how do you find all the L2s? How do you find new L2s that pop up?
That's a question that is asked really often. I mean, in this Devcon, at least to me. And the answer, I think, is way less interesting than it appears. Like, I think that half of L2BEAT is just chronically online, so we are on Twitter and we just know what is new. Also, projects just come to us and ask to add them. Also, projects just make a PR to our repository to add their L2. So right now, we have also we have a public Discord. So like there are many ways to basically message us about like, hey, can you review us? And right now we have around like 100 upcoming projects. So anytime this project will go into the mainnet, we'll move it from upcoming to the main page. But yeah, like I don't think there is any way. We don't have like a discovery for L2s. It's just like seeing what happens in the space, and that's it.
So how do you prioritize that?
How do we prioritize? So the thing is that certain projects, if a project is an offshoot of an OP stack, it is comically easy for us to find it. It's like less than an hour. If a project is more complex, so the prioritization always depends on how big the project is, how easy it is for us to add it, and also how many times they message us on Telegram per day. So yeah, there were certain projects. For example, I know that ZK-Link Nova has been in the waiting queue for a long time. They had a mainnet and they were waiting for a really long time because we just, we never saw this project before. So yeah, like we have to prioritize as anything else.
Can you consider just giving them the tools and say, you give us your configuration, you run this stuff, you figure it out?
So the funny thing, so the funny thing is that so I'll tell you that. So certain projects come to our GitHub, make a PR, and they have, their config JSON-C ready. They discovered all of this. They made the config file in TypeScript. And I don't think we had a single instance of an external team getting this right. So, I mean, they do try, but maybe it's a fault on our part because we don't have the best tutorials on it because like we didn't expect anybody to be using it, and we are expecting only us to be using it. Of course, this could change in the future, and we could say like, you need to provide a config.json file, but at the same time, if they provide a config.json file and it's small, like I said, it takes less than an hour for us to do. And if they provide a config.json file and it's huge, then we still need to look into it either way. So it's just, yeah. Okay, I hope that for people that are way too ambitious, they managed to do it. I'm just going to like flash things on your screen to go through it. Okay, if your config looks something like this, and you have no errors except the X domain messenger, then good job. So the X domain messenger error is also a fairy tale to be told, I guess. It's just, it doesn't provide anything useful and we ignore it. It reverts if you do a delegate call to it. You need to call the implementation. We always do calls through the proxy. But the output of it is not useful. It like returns, I think, some chain ID, which we already know. So we just ignore it also for any OP stack. Okay. So we don't have any errors. And we can now move on to handlers. So handlers are a way to get more state. Like there was this great question about like how do you find the state in the mappings? Because mappings don't have a good way to see what's inside. So we have handlers for a lot of things. So there are handlers like this is the event. Count how many times it has appeared, and put the number as the state variable. But these are really complex handlers, and I think like it will only confuse most of the people if I just start using handlers that are way too in-depth. To be honest, some of these are really complex just because we try to cram as much things into a single handler as possible. So to be honest, some of these handlers, I don't even know what they do. So a simple handler that I can show is if we go back to discover.json. And let's look, for example, let's say I'm interested in Gnosis saves, right? So I find me a Gnosis save and I see that there are members of this Gnosis save, which are the same as owners. And I'm just thinking, okay, so these are some raw addresses, but the thing is, what I'm interested in is like, is a given address an admin, right? So let's say there's some actor with a known address and you just want to know whether he is an owner or not. Of course, you could do like Control F and find it, but there's like a better way to do it. So if we look in the ABI of any Gnosis save, so you need to get the ABI, you need to copy the implementation. if you look into the implementation of any Gnosis safe, there is a function like this, is owner. You give it an address and it turns you whether this address is an owner or not. So we'll try to see if Vitalik is an owner of some random multisig, right? So let's copy the name of the function and let's go back to the config. And maybe, yeah, we also need the address of a Gnosis safe we want to do it on. So first, let's get the address. So this is the address we are going to be checking for is Vitalik an owner. Maybe this one. I don't want to break my presentation because I know there is one address which is different. But okay, so we are going to check is Vitalik an owner on this Gnosis safe. So it's the same as anything else. You just go to the config and you do some additional configuration for this contract. So now you need to say that what you actually want to configure is the fields part. So fields. And in the fields, you want to create a new field, right? So the name of that field is like, is Vitalik an owner? And the value of that field will be generated by a handler. So to say that, we are saying handler. The type of the handler is a call handler because we are going to be calling some function to get the value of it. And there are two additional arguments, which is like, what is the method we want to call? We want to call is owner, and also want to pass in that address as an argument, right? So we say args. And now we need to get the address of Vitalik, so let's just go to etherscan. Copy the address and add it. The args is an array because functions can take arbitrary amount of args. So for this example, it's only a single argument function. So if you do it like this and then rerun it, it should okay, maybe that did not work. Let me see. Okay, I guess I didn't save the file. So you saw this little hiccup that was there. Like most of those reruns are like really quick. It hiccuped because it was actually doing that call. It didn't reuse it from the cache because it didn't cache that call because it never did it before, right? So now is Vitalik an owner? False, right? So good job. So now I'm actually going to get to the flat files because it's going to move us nicely to the last part, which are the templates. So flat files, I have some slides for that. So we have built a custom flattener for the discovery. And I'm just going to try to convince you, or maybe I don't, to why we need this. So we are working on this L1 standard bridge contract, and as you can see, there are 33 files, which is the result of teams reusing code. OpenZeppelin being the standard library, they are trying to make the modules smaller and smaller. There is a lot of inheritance implementation of stuff. There's just also one thing I'll talk about, which is ballooning the amount of files in each contract. And if you try to visualize, like it's a single contract. Like, do you know what's happening? Like, imagine you're a researcher and you're like expected, like, yeah, good luck. And the funny thing is that if you look really closely, we are only interested in basically the blue contracts, and anything else we are not interested in. So if you look on the right-hand side, there is superchain config. It doesn't do anything with the implementation of the superchain config, but the thing is that teams more and more are basically reusing contract implementations as if they were interfaces. So when you do that, every single thing that this implementation uses is now also pulled in. And it doesn't have to be this way, right? So if superchain config changes their source code, it doesn't affect the bytecode generated by the Solidity compiler for the L1 standard bridge in any way, right? So if you cut all of this out, if you only leave contract libraries, stuff like that, that will affect the bytecode produced, you'll get something like this, right? Which is way more manageable. You have like 8 contracts, I think. If you take all of those contracts and like concatenate them together, you have like one big L1 standard bridge. So this is the reason why when we were looking at the code, we only saw a single file. That's because all of the files that we do write out from discovery are flattened by default. So it's really useful because we rely on those flat files a lot, because if you know that the source code in that file, when changed, will affect the bytecode, you can just focus on that source code. And the way we do it is we are using a parser for Solidity. It parses the Solidity, all of the files coming from EtherScan. Then we get an AST. We interpret the AST to find all of the contracts starting from the L1 standard bridge, which do actually affect the bytecode. So let's look at those flat files. They are here, and they are in folders if they are behind a proxy. So for example, address manager is not behind a proxy, it is immutable. But the L1 standard bridge that we are focusing on is behind a proxy. So the proxies get also flattened, and this is the entire thing you would want. So why I'm talking about this is that if you flatten the source code of every single contract, of every single project you have, you get some nifty bonuses basically for free, right? So since I see that we have a lot of time, I'll show you something that we have in L2BEAT and that we use sometimes. So or maybe I'll not be able to show you that. Yeah, but the initial idea is that we have built a script that will take all of the flat sources and then compare the similarity between those flat sources to each other. So then you get like a big list which tells you, okay, so this project has this percentage of similarity to this different project based on the source code. Let me just try to see if it maybe will work. Okay. If the internet gods will bless us, we'll get it. Unfortunately. So if you really want to see this, I'll try to get it working and I can show you this after the workshop. We are able to basically cluster projects together based on their source code, and we get automatic clustering of, let's say, OP stack projects, and it works really well. You actually get like different clusters for projects which use fraud proofs and for projects which doesn't use fraud proofs. So it works surprisingly well. Okay, but let's get back to the workshop. So let's see the config. So let's say that you are not, you're not so certain about this single Gnosis safe, and you think that maybe they'll try to sneak Vitalik as the owner into some different not as safe. So what do you do if you want to manage this handler in two different not as safe? So the first instinct is just to copy this entry and just repeat it, just change the address. So let's just do it. Okay, so we are going to be checking for Vitalik in this not so safe. So now in discover JSON, is Vitalik an owner? Is in two places, right? So it's here and here, right, on line 45 and 174. But if you look, like, it's not really the amount of things that we have changed, it's only the address. So just as with code, like, there's some duplication, right? And if some duplication happens in your source code, what you do is you create some abstraction that says that all of this functionality or behavior can be encapsulated to a single function, a single class, whatever, right? So how can we do the same? How can we pull out this configuration, call it something, and reuse this across contracts, across components? So this is where the templates come in. So in discovery, I will have to show you this way. So in discovery, we have discovery here, and if we do, if we list, we only have Zora, but we have to create a directory underscore, it's templates, yeah, underscore templates in discovery, and it will, just as discovery houses all of the projects that we have, templates will house all of the templates that we have inside, right? So let's create that, and let's create our template. With something that's weird is that templates are not files by themselves, they are folders. Why this is the way that it is, it will appear, it will explain itself in a second. So I'm just creating in the templates, I'm creating a single template called my template. I mean the directory for it. So we are creating this directory for the my template, and let's create a new file inside, which is template.jsonc. And we can just, as with code refactorings, we can just take out in the config the thing that we need to pull this out into a separate file, and that's it, basically. All we need to do right now is say extends, and we say the name of the template. And we can do it here also. If we rerun and check the discover JSON, it is still in two places, right? So what this gives you is a lot of leverage. So let's say that I want to see if maybe somebody else is also an owner in Gnosis Safe. So let's see if a different address is an owner. So since I don't know any addresses, I'm just going to use dono.eth. And it's the same thing as before. We are creating a new field. We are going to call it is Dono an owner. And pass in the argument. And let's rerun every single thing. Okay, and now in two places, there is Vitalik and is Dono, right? So is Dono, is Dono. As you saw, we only had to change a single file. And in the case where there is only a single project, it's maybe not that useful, but like imagine that we have thousands of L2s and we want to check something across those thousands of L2s. Changing only a single file instead of all of the configs for different projects is way more useful. And the way that we use this template is we said manually that, okay, use this template. And this can also get pretty boring. And let's say how many Gnosis saves are here. There are 9 Gnosis saves inside of this discover JSON. So I could either repeat myself 9 times in the config, or I could allow discovery to somehow automatically associate this template with any contracts that look a certain way. So this look a certain way is where flat files, again, come back into the picture. So what we can do is, like I said, like if we flatten a file and we know that this, the code inside that file, when changed, will change the bytecode. And if we say, okay, so the source code of this thing is something. So for example, here, we'll be saying the source code of this is a Gnosis save. So we can, in the my template, this is why it's a folder, we can say, okay, we have some shape files, which essentially means if anything looks like this shape, match that template automatically. So to do that, let's just go to the flat files and pick the implementation. The only thing I have to do is copy the implementation and paste it here. And now, when I rerun the discovery, you can see in the logs that there are logs about certain Gnosis saves being associated with a template, and the reason being by shape match. So essentially, what has happened is we have downloaded the source code for this contract. We have flattened that source code, and what we did is we found that the shape in this contract, in this template, looks like the source code for this contract. So we have automatically assigned this to this contract. And this can get pretty powerful. This is why I'm saying that for certain OP stacks, like it's less than an hour. So the only thing that we have to do is just like input a single address, and the discover JSON, like the output, looks the way that we want, right? So if the team did not do anything fancy, did not do anything too custom, it just works, right? So if we now look into the discover JSON, there are 7 instances of is Vitalik an owner. The reason being, like I said, some teams change the implementation of certain things just a little bit, and if it's not even if it's like a little close, we still don't do it. It has to be 100% the same. We also have run into problems where the source code is the same, but for example, one team uses a certain style of indenting or one style of formatting their comments. So we also have a formatter, like a really, maybe not human-friendly, but really computer-friendly formatter that takes the source and formats it into the same, like minified, yeah. And then it can compare across files. And since this works so well, we can also remove these two. Don't forget the comma at the end, and rerun. We also have 7 entries. So I see that I'm doing it way too fast. I have still 40 minutes. So like it's basically, this is the end of what I wanted to show. I can try to show you some of the things that we have in L2BEAT that make researching the things simpler. So maybe let's start with going back to this diagram. So we have talked about, if you look on the left side, on the inputs, Templates are also inputs to the discovery. We also have talked about flat sources. And flat sources, like I said, are used to compare project similarity. We talked about protocol beat. The only thing that we didn't talk about is update monitor. So I said that our needs are that to have the ability to react quickly to changes inside the project. And update monitor does that, like solves this problem. So what update monitor is, maybe I can show it. I hope I don't have anything embarrassing. I don't know, do I have an embarrassing internet or is Discord embarrassing? Yay, okay. This is our update monitor. So what update monitor is a bot or like a program that takes each project, reruns the discovery on it every single hour, and then does a diff on the discover JSON to see if anything has changed. And this way we can get like the maximum amount of time for which the update can be stale or the data can be stale for on our website is 1 hour. And you know, even here in the Discord channel, you have quite a good understanding of what has changed. For example, yeah. So this is an amazing example. So Molten has done a upgrade of their RBOS to a new version, and like we have descriptions and severities to help us understand what has actually changed, right? Because somebody has put the time and effort to understand what is a WASM module root, what is an RBOS from, this is basically the same, but it's like translated. So somebody has put in the time and effort to understand all of this, and we add like additional descriptions to the config JSON, so you can know after the fact what has changed to be able to understand the change even quicker. And we do something like this where every single day we have a like a summary of all the changes we need to look at. So as you can see, for example, this is actually a lot of changes we need to look at. The way that it connects to our website is that if any project has an implementation change, so you can see, for example, that Tycho is right here in the waiting queue. And the way that it works, if a project has an implementation change, it's automatically moved to in review on our website. So if you go to L2BEAT and check out Tycho, it is in review right here, and nobody has moved it to be in review. It was automatically moved to in review, and we want to show to our users that, look, this implementation has changed. Some of the things that we are saying might not be correct, and we even, I think, show to the user which implementations have been changed in the smart contract section. Yeah, so now you know that the implementation of these two contracts is different, so now be careful. Either you can wait for us to take a look at it, or you can just accept the risk that comes with it. And yeah. So that's update monitor, and I think I'll end it at that unless you have any questions. So we were really ambitious to categorize every single field inside the discovered JSON and assign it a severity, right? So for example, let's imagine there is Vitalik an owner, right? Or like we have that somebody cannot become an owner because the world will explode or something like that, right? Then we would assign this field a high severity. So anytime this would change, we would sort this project to be higher because something with high severity has changed. As you can see, there is also this fourth column, which is nobody has assigned any severity to it. And most of the projects don't have any severities. I mean, most of the fields don't have any severities assigned to them because it's just a lot of work to do so. But yeah, does that answer your question?
Yeah, so the fields are predefined. Severity of the changes were predefined.
Yeah.
Thank you for the answer.
Two quick questions. One is, it looks like you associated templates with a given L2. So, is that right? Or did I miss
We associate templates with a given contract. I mean, with a given implementation of a contract.
Okay. And so, if those templates are buried in a given project's config, is there a way to take templates and make them global? Is there any kind of template hierarchy?
Maybe I can show how templates look in L2BEAT. Because all the things that I showed are not maybe amazing. Leave me alone. Okay. So this is the, can you see it right here? It's good? Okay. So we have the templates that are in L2BEAT. And what you can do, you can create directories inside the templates and then try to categorize each template for like a given stack. So for example, we do associate templates not maybe with L2s, but like the stacks that they use. So we do have an OP stack template, like there are a lot of templates. So for example, the L1 standard bridge has its own template right here. It looks like.
Yeah, okay, that's what I expected. An answer to my question.
Okay, yeah.
And then the other question I had was, I assume that the web UI that we're looking at is entirely generated from this information. Is there any information that shows up in that UI that's out of band, that's done manually or so?
No. I mean, all of this is like every single thing. So, for example, let's go back to the UI. So this is Zora, right? So every single thing that we are showing for Zora is on my laptop and would be the same result if we were to run it on the data that we have found in the workshop session, right? So we are not making any additional calls to anywhere else. It's all local, basically.
Thanks very much.
I didn't quite catch how to load in the discovered JSON into this discovery tool on the website profile.
Oh, yeah, so there are two tools. I know it's maybe confusing. So this is Discovery UI, and it has Protocol Beat in it. But to load something into the Discovery, it shouldn't say Discovery UI at the top, but to load something, you just take the Discover JSON and drag it onto the website. Okay, any more questions? So I specifically chose Z for this presentation because any single time I try to share my terminal, and because I use Vim, so it would be just way too distracting to like try and show, you know, workshop stuff on the terminal. But this is Z with Vim bindings. Okay, thank you.